Hello and welcome to 4.8, problem solving using polynomial equations. So we've spent a lot of time learning about factoring and how to solve polynomials when you're factored down and set equal to 0. So today we're going to look at some situations in which these ways of solving them could actually be helpful. So the first couple of them are going to be more math-based, not as much application. And then we're going to start working a little bit into the application. And once we get into application, then there's context to what we're doing. And once you get that context, it's important to check and make sure that the solutions you get will actually make sense in the context. So it doesn't change the fact that that would be a solution to that math problem. It's just it doesn't fit the context of what we're doing, so it wouldn't make any sense. But these first couple are not that type of situation. Okay, so for these first two, right, the first one says two numbers differ by 5 and have a product of 84. So there's a handful of different ways that you can do these, but we've done a lot of writing little systems of equations and solving them, or just setting up of equations in general. So if you set up two equations, or you just set up the fact that the first number is going to be x and the second one has to be differing by 5. So you actually could write it as x plus 5 or x minus 5. You'll still get the same answers in the long run. And we know their product has to be 84. So that means that x times x plus 5 has to equal 84. So at this point, right, we can distribute this x and get that x squared plus 5x equals 84. But we need to get it set equal to 0 so we can use the methodology that we've been learning. So we're going to subtract 84. So x squared plus 5x minus 84 equals 0. So now we factor this, so x and x, because that's the only way to get x squared. And then we have this negative 84. So what are the factors of negative 84 that will add up to a positive 5? So that would be a positive 12 and a negative 7, because 12 times negative 7 gives you the negative 84. Positive 12, negative 7 gives us a positive 5. So then we set this equal to 0. So now we can set each one of those components equal to 0. So we will subtract 12 from both sides, and we get negative 12. We add 7 to both sides, we can get x equals 7. So we actually have two situations in which this will work. The first one is if x is negative 12, and then x plus 5, right, so this is our x, and then our x plus 5 would be negative 12 plus 5, which is negative 7. And then if our x is 7 and we add 5 to it, that would give us 12. So those are the two situations in which this gives us the solution that we're looking for. Okay, the next one is the same exact type of problem. Okay, we have the sum of the number is 9, or of two numbers is 9, so we know when we add these two together, they're going to equal 9. X plus y. Okay, has to equal that 9. And then the sum of their squares is 101. So x squared plus y squared has to equal 101. Well, this top one we can very easily solve for x or y. So if we subtract y from both sides, then that would give us x equals 9 minus y. I can then insert that in for my x down here. So I can take this and put it in for x. So 9 minus y squared plus y squared equals 101. So now I'm going to use my factoring, right? Or this is the reverse factoring, right? So we're going to multiply it out, and I can use my rules. So I know that this is 81 minus 18y plus y squared. And then we have this plus y squared equals 101. So most of you guys don't like them in this order. You like to have your y squareds out in front. So we can go ahead and rewrite it in that order and combine like terms while we go. So y squared and y squared would give me 2y squared. Then I have minus 18y. Then plus 81 has to equal 101. But we know that we need to get this equal to 0. So we have to subtract 101. So minus 101 from both sides. So 2y squared minus 18y minus 20 equals 0. So at this point, we want to factor this down. So the first thing hopefully most of you guys notice is that you can pull a 2 out of each one of these. So if you factor a 2 out in front, then that would be y squared minus 9y minus 10 equals 0. So now I can factor this. You can do it the other way and still get the same answers. It's just a little smaller and easier numbers to work with. So the only way to get y squared is y and y. To get a negative 10 but a negative 9 here, we need a minus 10 and a plus 1. So then when I solve, my y minus 10 has to equal 0, or my y plus 1 has to equal 0. So we can add 10 to both sides. Y can equal 10. Subtract 1 from both sides. Y can equal 1. So those are actually our, negative 1. So that's actually our answer, right? Our two that work, right? Because if you put these back in, right, x plus 10 has to equal 9. Well, when you subtract 10 from both sides, you get x equals negative 1. And then you'll get the same thing, right? If I do that x plus a negative 1 has to equal 9, you get x equals 10. So then the pairs that work, or you could have 10 and negative 1, and negative 1 and 10, which is the same thing. So those are your solutions. Okay, now when we flip this over and we start working on the back of this one, okay, we're moving ourselves into real life situations. As far as drawing a picture, okay, can super help with these problems. So here we're talking about the length of a rectangle is 1 meter less than twice the width, and the area is 55 meters squared. So there's a few pieces of information we want to take into consideration here. Okay, area, right, is length times width, and perimeter is 2 times length plus width. So when we do this problem, right, this gives us our area, our perimeter, so we have the two formulas we need to make it work. So we're going to draw a picture of our rectangle, right? Our width, we don't know, so that's x, and our length, right, is 1 less than twice the width. So 1 less, minus 1, then twice the width, 2x. So it tells us that our area is 55. So 55 has to equal my length times my width. So 2x minus 1 times x. So we distribute that through. So 55 equals 2x squared minus x. We need this equal to 0, so we're going to subtract 55 from both sides. So 0 equals 2x squared minus x minus 55. We then need to factor this down. So 2x and x, one's going to be plus, one's going to be minus. Remember, it does matter which one is where because our first ones are not the same. So if we do minus 11 and plus 5, that gives us plus 10 here, minus 11 there, which gives us the minus 1 overall. And then we still get this negative 55 that we need. So now we can set each piece of this equal to 0. So then we just go to solving. 2x equals 11 divided by 2. X could equal 5.5. Subtract 5 from both sides. X equals negative 5. So now before we go any further, we solved. So now we need to ask ourselves, okay, do these make sense? So that's kind of my next step, right? Do these make sense? Or does this make sense? So does it make sense? Okay, does it make sense for x to equal 5.5, and does it make sense for x to equal negative 5? Well, we're talking about the dimensions of a rectangle here, and if we're talking about the dimensions of a rectangle, we can't have a negative number, so that makes no sense. Having this positive value, that makes sense. So now I'm going to continue with just my positive value. So then my perimeter would have to equal 2 times my length, which is 2 times 5.5 minus 1. And then that would be plus my width, which is just 5.5. So my perimeter equals 2 times, and then 2 times 5.5 is 11 minus 1 plus 5.5. 11 minus 1 is 10. So 10 plus 5.5 is 15.5, so 2 times 15.5. So my perimeter equals 31. We're given a measurement up here. It's in meters and meters squared, so we need to make sure that we label this for full credit. And since perimeter, right, is just the length or the distance, it's just meters. So your final answer is your perimeter is 31 meters. Okay, number 4 says 2 ships leave port, one sailing east and the other sailing south. So if we think about it, right, on a compass, on a page, this is north, south, east, and west. So if we have a starting point, right, we have one ship that's going south, we have one that's going east. Now we're looking at a specific point, so instead of leaving the arrow there, I'm going to take the arrow away. Okay, and it tells us that these are 17 miles apart. So if I go from here to here, that has to be 17 miles. It says the eastbound ship is 7 miles farther from port than the southbound. So my southbound, right, is X because my eastbound is based on that. So my eastbound is X plus 7. Now you may notice that this right here has to be a right triangle. So since this is a right triangle, that means we can use Pythagorean theorem of a squared plus b squared has to equal c squared. So x squared plus x plus 7 squared has to equal 17 squared. So then x squared plus 14x plus 49 has to equal 289. So x squared plus x squared is 2x squared plus 14x plus 49 equals 289. We need this set equal to 0. So we need to subtract this 289 from both sides. So 2x squared plus 14x minus 240 has to equal 0. Again, we have a common factor in all these, so we can factor the 2 out. So that leaves me with x squared plus 7x minus 120 equals 0. So now we need to factor this. So when I factor that, right, x squared, the only way to get it is x and x. One's going to be plus and one's going to be minus. So what are the factors of 120 that have a difference of 7? Okay, and the answer is a positive 15 and a negative 8. So then either x plus 15 is 0 or x minus 8 is 0 to solve for it. So I add 8 to both sides to get x can equal 8. I subtract 15 from both sides to get x equals a negative 15. And then I back to the point where I have to ask myself, do my answers make sense? So, does it make sense? Okay, so a negative 15 and 8. Well, a negative 15, right? I can go 15 miles north, south, east, west, northwest, southeast, whatever, right? But I can't go a negative 15 miles, so that makes no sense. But 8, on the other hand, does. So then that means that my boats, right, were traveling, one was 8 miles south, and the other one was 8 plus 7, or 15 miles east. And yes, when you write out your answers, they should be that detailed. It should say 8 miles south, 15 miles east. If you don't answer it that specifically, you will lose partial points because of the fact that you didn't properly label your answer. And then the final one on the notes for tonight, okay, is the vertical motion problems. So this is something that you'll use a lot in physics. This is actually a really neat parabola that I wish we had more time to work with. So this formula is a scientific formula, and it has to do with the height of an object, okay, traveling at a velocity over a set amount of time, okay, given that gravity is the only thing that's going to actually affect it. So it's given here in both meters and in feet. So it's really important when you're looking at the question that you check and see what measurement your values are given in, so you're making sure you use the correct formula. So it says a ball is thrown directly upward from the ground level with an initial velocity of 80 feet per second. So we're talking feet per second. So we know that we're going to use our h equals vt minus 16t squared. So it says, when will the ball hit the ground? Well, how high is the ball when it's hitting the ground? Well, it's at 0, right? Because it'll start there and it should finish there, right, when it comes back down. So that means we want to know when will 0 equal our velocity, which was given to us as 80 times t minus 16t squared. So our first step is to factor out anything that we can factor out of here. So you can factor out a 16 and a t. And then that leaves us with 5 minus t. So then if 5 minus t equals 0, then the entire expression equals 0. So that just means that we need to subtract 5. You get negative t equals negative 5, so divide by negative 1, and you get t equals 5. So when will the ground be back on the ball? After 5 seconds. So the answer to the first part of the question, right, so first part is 5 seconds. Okay, then it says, how high will the ball go? Well, the ball will actually travel the exact same amount of time up is what it travels back down. So if we take this and we take half of that, so 5 divided by 2, so we're looking at 2.5 seconds in. So we can put in our velocity again is 80 times our time of 2.5 minus 16 times 2.5 squared. Okay, and when we do that, okay, that's going to give us 200 minus 100, which is 100 feet high. So our second answer is 100 feet high. Okay, that's how far the ball will travel in the air. So hopefully you found that helpful. The homework for tonight is on page 200. It's 5 through 15 all this time, but make sure you skip number 8. Hopefully that's helpful. If you need any help or have any questions, just let me know. We will spend some time tomorrow in class going over some more 4.8 and answering lots of questions. Have a great night, guys. Bye.